Hello and welcome to May I AI. This is Mustafa and I'm Alexander, and we're your hosts today. In the last pilot episode, we talked a lot about large language models and their ethics and what they can do and cannot do and the challenges and so on. But there's also other types of artificial intelligence, and today we'd like to expand our horizon. So AI is everywhere, right? It's not just ChatGPT. And it's also really important for you to understand what it can do and what are its chances, what are its risks and so on, so you don't get scared and so you know what are the capabilities here. So, Mustafa, what kind of types of artificial intelligence exist?
Well, artificial intelligence is like very big, but we can kind of divide it into two big subgroups. The first one is like logical AI and symbolic AI, and then there's modern AI. Now, symbolic AI is what started back in the 1900s even, and the whole goal of it was how do we create machines that are able to do what people do very trivially. And it kind of works with logics and predicates, and it's all about inference. So basically, when you decide to ask a series of questions based on information you already know, you are able to prove everything because you have predicates that relate to one another. And then modern AI, on the other hand, is a way to look for patterns. So it kind of grew out where people were like, how about we stop doing what people do trivially and try to do what people cannot do very easily. So if we can locate objects very quickly in one image and look for patterns in a very fast way.
So the difference here is that the classical symbolic AI, it's a very human driven thing where humans actually have to do the deductions, right? Whereas the modern AI is very data driven. Is that correct?
Yeah, so for symbolic AI, you usually have to write a lot of the predicates and how they connect to each other.
Mm-hmm.
You kind of have to explain how everything works. Where for modern AI, you just have to get a whole lot of data and you just feed that to your model.
So how does the training of a modern AI system work? What are the ways? Can you explain that?
Yeah, well, we can look at the model for now as a black box, right? And we can try to say we have this whole lot of data, and then we want to feed that to the model for it to learn about a certain pattern. So let's say we're talking about a classification problem where you have an image of cats and dogs, and you want the model to be able to understand what a pattern of a dog and what the pattern of a cat is. And then you have a picture of a cat, you show it to a model, and the model tells you that's a dog. And you're going to be like, no, that's actually a cat. So a model is going to be like, okay, that's a cat. And then you show him another image and so on and so forth. And if you do that with enough images, the model and basically humans are going to be able to understand what classifies cats and dogs. And this is the whole premise, kind of.
So a model kind of learns from the experience that you're already giving it with the data.
Yes, exactly.
So you just mentioned that there's an image and it says it's a cat, but a lot of the data that we have, a lot that is on the internet, doesn't have that label. How can we train an AI model if we don't have that label? Is that also possible?
Yeah, so the trivial answer is you want to get someone to label it for you. And then the non-trivial answer is there a way to actually let the model decide on its own what the labels are? And the answer is actually yes. So having labels that classify each of your images is called supervised learning. And then we have something that is called non-supervised learning, where we have a bunch of images. It could also be cats and dogs, but I don't know which images are cats and which images are dogs. So what the model will try to do is that it will look at the patterns for each of the images that look similar enough to one another, and it will put them in the same class, and then it will divide them. And what you have to do as a user is decide how many classes do you have. Now, does this always gives you cats and dogs in different classes? Not necessarily, because you didn't really decide what the classes are. So it could decide based on color. So basically every cat and dog that have a black fur is going to be on one side, and then everyone else is going to be on the other side.
Is there a way to kind of combine that, both the label and the unlabeled?
Yeah, so there's also methods of training that are called semi-supervised or self-supervised. And it's kind of a combination of self and supervised and non-supervised learning. And imagine for once, actually Facebook uses this, where imagine I have a picture of myself that I know it's me, and then I have a bunch of pictures by other people posted that doesn't say it's me. So basically if I can do some facial recognition and then I compare it via the non-supervised ways of combining stuff together, and assuming that all of the pictures of you are going to be in the same, let's say, cluster, if I know one image in this cluster, I know all of the other images. This is kind of where semi-supervised comes into play. Self-supervised, on the other hand, is a way by also getting one image that we kind of know what the label is, but we let the model decide what the labels are, so pseudo labels for every other images, and then we can use that as a label for all of them and use supervised learning.
So there's one thing that you didn't mention, which is reinforcement learning. How is that different? How is that more interesting?
Well, reinforcement learning is a very interesting way of training because it's still data driven, but it's based on an objective function rather than on a label. So most people actually use this for games. So if you see a game where AI is playing, like AlphaGo, chess has been done with reinforcement learning, and so many other games, you kind of only have to decide what am I trying to do better. So for example, for games that have a score, you just say the objective function is increase your score. You can be like get the minimum number of errors, and then you let the model do its thing. And it's very fun to look at because you don't really explain what you want the model to do, and the model figures it out. And there's a lot of videos and stuff you can look at where the model comes up with better ways than every other human, and kind of even breaks your game, because it figures out new ways of its own.
Yeah, I have seen that before, where the reinforcement learning model hacks Super Mario and just hacks it to give it like a super high score, which is obviously not playing the game, but it did achieve the objective function here.
Yeah, exactly. There's also, you could look at the hide and seek by OpenAI, where they created multiple agents. One of them is a hider, the other one is a seeker, and they just let it do its thing. And first of all, they just kept running away from each other. And then the hider realized that there is an object they can close the doors with. Eventually, the seeker realized it can jump into the room, and it just started getting better and better along the way.
So to sum it up, reinforcement learning tries to optimize for some sort of function, whereas all of the other supervised, non-supervised, semi-supervised, and self-supervised methods, they're always about labeling and saying like, this is either this or it's that.
Yeah, depending
classifying.
on, like for its classification, yes. And you can also, if we want to go into a bit of a technical level, they kind of also have a loss function that they're trying to reduce, but it's all based on what labels that the user creates.
All right. So now we've talked about how to train the box, but what is the black box? Like, what is it that we're actually training?
Right, so the black box can also be kind of divided into two methods. We have like this classical AI, and then we have the more advanced machine learning, deep learning, right? So classical AI is basically the easiest thing you can think about is trees. And the tree is a bunch of if conditions. But the way you create the if condition is based on your classes. So it's kind of learns how to set up our if-else statements. So if you have a cats and dogs, and then you have features like how big how size of the animal, the tail shape, ear size, whatever. And then basically, if you're doing it by hand, you're going to be just checking everything. But your tree is going to try to check different, like it's going to try to understand which features make more sense to ask first, and then which sub features matter after each first feature. You can also look at classical methods like clustering, which is a non-supervised method, and we talked about it before. And it kind of puts all of your features in a space, kind of, and then decides how many classes do I have. So let's say I have 2. And it kind of tries to find the best position for each of your 2 classes among your space of data. And then every point that is closer to your main point is going to be that class, and so on.
So it's kind of like the clustering. It's trying to find similarities.
Yes.
It's trying to find like all the similar, I don't know, all the cats, they're kind of similar because they're all cats, and the dogs are all similar. So it's trying to cluster it that way.
Yeah, exactly. It pretty much heavily depends on how your features are looking.
And so that was trees and clustering. What are the other methods that exist?
Well, machine learning and deep learning is what people have been hearing very recently, and it's basically mathematical functions. It actually started by the equation of line. So everything new about machine learning that you know of today started with y is equal to mx plus c. And this gives you a line that kind of fits to your points, right? And then if you want to think about classification, you're going to say, well, every point above the line is one class, every point below the line is another class. And if you're trying to figure out the continuous value, you can just try to find the point on the line, which is pretty nice. But then problems are a bit more complex. One line cannot simply do everything you want. Well, you can try to think about, well, let's add like multiple lines. So you have like x1 and x2, and then you create multiple lines, and then you can think about putting them together. And then once you add multiple, let's say, layers of this equation, you have a lot of capacity to learn a lot of stuff, but they're all pretty linear. And then if you add a bunch of functions on top of these, you end up with what a neural network is. And neural network is like what machine learning does, basically, and then to make it deep, you just need more layers.
So machine learning or deep learning is basically just a lot of functions stacked onto each other.
Yeah, exactly. So most AI now is a bunch of mathematical equations. This is why it really helps us estimate bigger mathematical functions.
Well, that was really interesting. Thank you for listening to May I AI. This was the last pilot episode, and stay tuned for season 1 coming soon.